Most people know that carbohydrates come in different packages with regard to foods. Most people even know which ones are good or bad for us. Some carbohydrates are typically bad for us. Some carbohydrates, brown rice, brown anything, natural foods, are considered good for us. So it's not just the quantity of carbohydrates you need to be concerned with, it's the quality of carbohydrates when you look at it from a molecular point of view. And that's what you should hopefully keep in mind. All carbohydrates get broken down into simple sugars. We talked about this. The sugar is a small enough molecule that can go into your bloodstream and then feed all the rest of your bodily cells. So the sugars that they're talking about in carbohydrates, the one your body likes to use is glucose. The one that you get in lots of fruits and some vegetables and things is called fructose, and they're single molecules, sugar. The other one that we get mostly in Western countries is the thing called sucrose, table sugar. Table sugar is different. It's one molecule of glucose stuck together with one molecule of fructose in a bond. It's not a particularly strong bond, but it's a bond that requires a bit of digestive effort to break it apart so that the sugars can then go into your bloodstream. In Western countries, the definition of a sugar is a carbohydrate that is less than 2 molecules big. So glucose, fructose, sucrose, lactose, they're all classified as sugars. If you get a sugar that's more than 2 molecules big, so 2 molecules to 10 molecules for example, then it's called an oligosaccharide. It's got advantages and disadvantages. And then if you get a carbohydrate that's more than 10 molecules big, such as this one, then that's called a starch or a complex carbohydrate. These ones can be anywhere up to a couple of thousand sugar molecules big. They come in different forms. These ones are even more complicated. They look like snowflakes, take a lot more digestive effort to break them apart. All carbohydrates are sugar molecules, it's just the way they're packaged together that either creates a metabolic benefit or a disadvantage. And that's what you need to try and keep in mind. Good carbohydrates, the starches and the complex carbohydrates, require a bigger digestive effort to snap off these individual sugars so that they can come into our bloodstream. We've got these other types of carbohydrates which have got the same sugars in them, but the bonds holding the sugars together are very, very particular and they're difficult to break down, so our digestive system can't do it, so they bypass us, they don't come into our bloodstream, and they go into our bowel, which feeds our bacteria that live there, and they're the ones that do all the magic for us with regard to our health, our weight and everything else. So the more we can feed that bacteria, the better we are. But we don't have to account for that type of carbohydrate in a food. So fruits always have a reasonably good level of fibre, so we can subtract that from the total amount of carbs that is in the food, because they don't come into our bloodstream. And then you've got these other ones, same sugars again. This time the bonds holding the sugar molecules together are different from a fibre, but they're also very, very hard to break down. So these are called resistant starches. And resistant starch simply means we can't break it down, it's resistant to our digestion, so it goes into our blood, into our bowel and feeds our bacteria exactly like a fibre tends to do. The key is that they don't come into our bloodstream though. We don't have to account for that carbohydrate energy value when we consume these. So foods that have got a certain amount of carbohydrate, if they've got more fibre and more resistant starch, the fibre and the resistant starch makes our digestive system work really hard trying to break it down, and that all requires energy. So that's called the thermic effect of food. Every food that we eat, proteins, fats and carbs, require a digestion effort, and some proteins have got the biggest digestive effort, so they can account for anywhere from 10 to 20% of the energy value of a protein gets used up just trying to digest itself so that the amino acids can come into our bloodstream. Sugars and fats, or carbs and fats, don't have as much. Sugars have got very, very little thermic effect. Fibres, resistant starch, and even good quality starches, they have a higher effect, could be 5 to 10% of the energy value of the carbohydrates, which means we get rid of them. We don't have to count them as part of a calorie awareness type thing because they don't come into our bloodstream. They're used up in the processing of itself. They're the things that we need to try and keep in mind. All carbs are not equal. All calories are not equal for that matter, and we're going to discuss that further on.